Welcome to myprojectbazaar.com. Our project title is Accessing the Suitability of King Topologies for Interconnection Networks. Abstract. In the late years, many different interconnection networks have been used with two main tendencies. One is categorized by the use of high-degree routers with long wires, while the other uses routers of much smaller degree. The latter rely on a two-dimensional mesh and torus topologies with shorter local links. This paper focuses on doubling the degree of common 2D meshes and tori, while still perceiving an attractive layout of VLSI design. By adding a set of diagonal links in one direction, diagonal networks are obtained. By adding a secondary set of links, networks of degree 8 are built, named King networks. This research presents a comprehensive study of these networks, which includes a topological analysis, the proposal of appropriate routing procedures, and an empirical evaluations. King networks exhibit a number of attractive characteristics which translate to reduced execution time of parallel applications. For example, the execution times are reduced up to 30%. In addition, this work reveals other properties of King networks such as perfect partitioning that deserves further attention for its convenient exploitations in forthcoming high-performance parallel systems. Let us see the flow of our project. First, in our project, main objective is to reduce the area and increase the throughput time and reduce the delay. So in that we have to give the input data first, then we have to design the NOC, that is our network concept. Our concept is a 4x4 King torus topology. Torus is nothing but includes diagonal as well as mesh topology, the interconnection between these topologies, and also the first node's feedback is sent to last node feedback, that is King torus network. In that we have to design 4x4, that is 4x4 matrix King torus networks. In that we have to implement the router determination. First, the node which is send the information, that is the node which sends the bit to the destination, is taken as source router section, which receives the bit is taken as destination router section. Neighbor router determination is calculated by our routing algorithm, that is DOR, dimension order routing. In that we use IVAL routing. IVAL is nothing but improved variant randomized routing. This is the type of obligate routing process. Then after all the process is done, that is data transmission is done, we have to evaluate our project. In that we have to reduce the area and we have to reduce the number of flip-flops count and the number of latches. Let us see the output of our project. After implementing all the process is given in the base paper, we have to run this project in our Xilinx. So for running our project we need Xilinx IDE. In that we implement this code. In this part we have create 8 degree nodes, that is our process is in 8 degree. So all the nodes, the source node which is act as a master process and all the other is act as a slave process. When we run on this, click in the left pane, click on the simulation radio button. In that we have to click this simulate behavioral model. This will produce our output window. This is our output window, which contains number of wires. When we set this reset button, we set this to 1 and we have to give the input data. this is my input data. There is 8-bit input data. Zero. So also we give the enable options. So when we run this, it will produce all other files in 00, because we have to reset first. We have to reset our data, and then give reset as 0. It will start the process. Now if we enable this data as 1, it will also start the process. So our input data is 01010101, and this is travel along these wires. So G02 G15 is considered as a wire, and P0 to P15 P16 is considered as a wire. So our process is 4x4 matrix, so 16 nodes are formed. When we run this, it will transform the data input data to the neighbor nodes, all are considered as a wires. So now our process is on P0. This P0 is acted as a neighbor node, and it receives a file from that input data. So now this output is an output is received, that is data out. So with 20 clock pulse it receives the output. So now we know that there is P0 is received first and P5, and then it traveled along P10 P15. Afterwards it translates the information to the data out. This is our output, and for our design summary, there is our evaluation report. We have to click on this and run this synthesized XSD. It will produce our view RTL diagram under the technological diagram. Our RTL diagram is, so this is our RTL diagram. So what all we given in the code is displayed as a RTL diagram. We doesn't want to create this RTL diagram. We only code it. It will generated automatically. So this is our RTL diagram, and our technological diagram is, this is our technological diagram. So what are all the memories are used and what are all the gates are used is produced in this technological diagram. And this is our design summary report. So how many latches we used, how many flip-flops are used is defined in this design summary report.